Hello, dear all, and welcome to another interesting webinar of MD Microdetectors. Webinar focused on our capacitive sensors. It's Giovanni Principe speaking now, the product manager for the ultrasonic and capacitive sensors in MD Microdetectors. And today I'm going to, let's say, show you all the advantages and technical features and the possible applications related to our capacitive sensors. A colleague of mine, Giovanni Di Lorenzo,
hello everybody,
who is the product manager for proximity and applicative sensors and for accessories, is going to support me trying to answer to all of your questions. So if something is not so clear in my explanation, if you are curious and you want to deepen your knowledge about the capacitive sensors, please do not be shy and do not hesitate to write your question down, addressing them to the Q&A profile. And Giovanni will be very happy to answer you. Right, Giovanni?
Yes, correct.
Okay, thank you very much. I think that we are ready to start, so let's go. What we are going to discover today. First of all, we are starting with an introduction, an explanation of the capacitive technology. So the objective is to understand how physically a capacitive sensor works. Then we are starting with the exploration of the MD capacitive sensors portfolio with a let's say detailed exploration of the different series, starting from the M12 models of C12 series, going to the M18 models, the 20 models with the CE series, the M30 models, CT and C30 series, and finally the cubic capacitive sensors of CQ50 and CQ55 series. Furthermore, we are, let's say, talking about all the most significant and interesting applications that we already solved thanks to our capacitive sensors. And finally, as always during our webinars, we are having a practical part where we want to show you how to adjust a capacitive sensor, in particular with a focus on a C12 product, where the adjustment procedure is based on a teaching button, and on the other side a C18 sensor, C18 model, where the adjustment is based on the trimmer. Okay. Let's start with the capacitive technology. So let's start with a brief explanation of the capacitive technology. What about a capacitive sensor? As the name says itself, a capacitive sensor works as a capacitor. In other words, it generates around the active head an electrostatic field. So any kind of objects passing through this electric field create some variations in terms of electric magnitude. These variations are caused by a metal plate installed internally and linked to an oscillator. When this oscillator starts vibrating, it can translate these oscillations into electric signals, into electric switching signals, and then we can produce our output. As I said before, the capacitive sensor, a capacitive sensor is able to catch any kind of material passing through the electric field. So both conductive materials like metals or water-based solutions, if you are talking about liquids, and also non-conductive materials, which acts like insulators. Let's think about, for instance, the plastic materials. But obviously these objects, these different kind of materials are detected with, if we keep the constant the power emission at different distances. So the conductive materials characterized by a higher dielectric constant are detected within higher sensing distances. On the other side, the non-conductive materials are detected in more limited distances, as we are going to see. So, which are the main factors affecting the performances, the effectiveness of a capacitive sensor in terms of sensing distance? First of all, the size of the active surface. In fact, as I said before, the capacitive sensor works as a capacitor. So, physically talking, it's important to have a very large surface in order to get a higher capacity, a higher electrical capacity. So it means that with a capacitive sensor, the larger the active area, the higher the sensing distance. And we are going to translate in practical terms this physical principle when we are, let's say, having a look to our portfolio and we are observing that for instance, cylindrical capacitive sensors with higher diameter can grant a higher sensing distance with respect to the other with a shorter diameter. By applying the same physical principle, we can, let's say, use this conclusion also for the target object surface area. So, also for the target object, the larger the surface, the higher the sensing distance. Another stuff very important, fundamental to take into account is represented by the capacitive properties of the target. Capacitive properties, let's say, translated in terms of dielectric constant. In fact, conductive elements have a higher dielectric constant, while non-conductive elements, non-conductive material, have a lower dielectric constant. And it is translated into higher power emission needed by the capacitive sensor in order to catch the presence of these objects. Let's consider now this comparison between these two kinds of technologies. On the one side, the capacitive technology, and on the other side, the inductive one. Why we have decided to, let's say, to compare these two kinds of technologies, both of them within our product portfolio? Because they can be both defined as proximity sensors, because they work within very limited ranges, limited sensing distance. But the first difference comes here. In fact, capacitive sensors are able to detect also non-metallic target surfaces, while the inductive sensors just detect metal target objects. And this is based on the fact that the capacitive sensors generate an electric field, while an inductive sensor generates an electromagnetic field. As a consequence, the target constant important to be taken into account is the dielectric constant for the capacitive sensors, while for the inductive sensors we have to consider the magnetic permeability constant. Let's start exploring our product portfolio with respect to the capacitive sensors. And we can consider this first picture where all the series, all the, let's say, capacitive series are present. In particular, we are considering here two different dimensions. On the one side, the sensing distance, and on the other side, the shape, the housing shape, with a distinction between cylindric and cubic sensors. As you can observe, here we can, let's say, can connect to what I said previously about the active head surface. In fact, if we observe the cylindric sensors, we can see that the higher the diameter, the higher the sensing distance. And so a C30 model with M30, let's say, thread has a higher nominal sensing distance with respect to a C12 with M12 thread. With respect to the cubic capacitive sensors, we have these two main series, the CQ50 and the CQ55. The first one is designed mostly for the civil applications and based on a connection with cable, has not the possibility of performing an adjustment. On the other side, we have the CQ55 with the adjustment by trimmer and the possibility of working also in industrial contexts. Okay, let's start with the exploration of different series. So let's start with the M12 models, C12 series. These sensors can work both in shielded and not shielded mode, shielded and not shielded installation mode. For the first case, they work with a sensing distance of 4 millimeters, while in the second case, they work with a sensing distance of 8 millimeters. But what does it mean that they work as shielded or not shielded sensors? In the first case, they, let's say, are within a support, within some walls, and the electric field is limited within a certain direction, as a direction which is, let's say, perpendicular to the active surface. In the second case, they are not so shielded, let's say, within a support, within some walls, and the distance can arrive also to 8 millimeters because the electric field is not so limited within the perpendicular direction. So they are able also to read materials, objects all around the active head. And you are going to see it with the C12 model during the practical part of this lecture. For what concerns the output, we have the sensor with digital output, PNP and NPN, and normally open, normally closed logic. I want to underline here the improved EMC performances of these sensors, which are based on plastic housing and with a possibility of having a plug M12 or a PVC cable of 2 meters length. The adjustment is based on the usage of a teaching button, and we are going to learn how to use it, how to play with this button. Let's move now towards the M18 models with the C18 series. Here we have different models for shielded and unshielded configuration, shielded and unshielded installation configuration. In the first case, we arrive to 8 millimeters of sensing distance, while in the second case, we arrive to 12 millimeters. And for what concerns the output, we have single digital output and double digital output, PNP or NPN. Also in this case, we have improved EMC performances, but the adjustment can be performed through the trimmer. And we are also going to see how to perform an adjustment with a C18 sensor during the last part of the webinar. Here, we can see the series, the CE series, which includes these models with a diameter of 20 millimeters. In this case, we have sensors working in shielded configuration with 10 millimeters of sensing distance and with double digital output. Also in this case, the adjustment is performed by trimmer. Let's consider now the M30 models. Starting from the C30 series, here a distinction between shielded and unshielded model can be performed. In the first case, we have a sensing distance of 16 millimeters, and in the second case of 25 millimeters, with a distinction between single digital output and double digital output. Also in this case, I underline for this series, we have improved EMC performances and the possibility of teaching the sensor through trimmer. Another, let's say, cylindric series of M30 thread is represented by the CT series. And also in this case, we have the shielded model with 15 millimeters sensing distance and the unshielded model with 20 millimeters, with an output of, with a single digital output, PNP or NPN, and the possibility of teaching through the trimmer. Now we can go on with the cubic capacitive sensors of the series CQ50 and QC55. The CQ50 series includes these very flat capacitive sensors for civil applications. And in particular, we have to make a distinction between models supplied by a voltage of 5 volts with a distance of 5 millimeters, and other models supplied by a voltage between 10 and 30 volts with distances of 7, 6, 10 millimeters, with an output, with a single digital output and just a connection with cable. Here, on the other side, we have a cubic sensor CQ55 series, applicable also in industrial applications, industrial contexts, and which can work both in shielded and unshielded configuration, with obviously different distances. In the first case as 16 and in the second case as 25 millimeters. 25 millimeters, which is characterized by double digital output. One difference that I want to highlight with respect to the CQ50 series is the possibility in this case of let's say of adjusting the sensing distance by trimmer, while the CQ50 series is based on a fixed sensing distance. And another difference with respect to the CQ50 series is represented by the possibility of having, in this case, a connection by connector M12 plugin over the connection with 2 meters PVC cable. Okay, let's start considering the most significant applications that we already solved with our products. We can start with this car washing application, where we want to clean our car with this plant. But basically, we need some soap, we need some water to do that. And if you want to have your car very cleaned and very shining, let's say, you have to have the right quantity of soap and water within these tanks. And how you can grant this service level? Simply by installing our capacitive sensors, which are able to, let's say, to detect the minimum quantity, the minimum level of this soap and water, making it possible to refeed the tanks and to grant the right service level. So please make it sure that your car is correctly cleaned and install the capacitive sensors to do it. Another interesting application refers to, let's say, to farms with some livestock. In particular, in this case, as you can observe by this funny picture, we are considering a little town of chicken, let's say. They are always very hungry, I can assure, and they need continuously to be fed by this automatic feeding system. Otherwise, if they do not find the right quantity of food within these dispensers, they become a little bit angry and they can, let's say, start to package the other chicken and also to kill themselves. So please stop letting them to kill themselves. Stop this, let's say, this horrible killing situation, and install our capacitive sensors in order to grant always the right feeding quantity and to make your chicken happy. Another interesting application is represented by the end of the line packaging application, where we want to make it sure to that the object was inserted internally with respect to the pack, to the box. Obviously, we cannot open the box, because otherwise we can disrupt the work already done. But we can leverage on the ability of a capacitive sensor to read over the wall of a package, in this case the cardboard wall, based on the fact that the object internally has a higher dielectric constant with respect to the cardboard wall itself. And we can use, in this case, the capacitive sensor in order to say, okay, the object is inside, no, the object is not inside, and to perform this quality check without disrupting the already done packages. Let's move now to another, let's say, very important application, very important situation related to the vending machines, where you can have your, during your, let's say, during your working pauses, you can have some hot drinks. Now, I don't know if you often enjoy this kind of, or stops this kind of pauses. Me, yes, and I'd like always to be served in the right way. I'd like always to have the right quantity of hot drink within my glass. And how to grant this correct situation? Simply by installing this capacitive sensor here, let's say aside of the tank of powder and of water, because we need both powder and water in order to make, let's say, coffee. And then I can have my coffee and I can be very happy of that. So please make your customers, your users happy, and grant that the right quantity within these tanks will be always them. At last but not least, in terms of applications, we can consider this stuff that we have already talked about during one of the first, let's say, one of the first webinars where we talked about some solutions that we have in terms of sensors for fighting against the COVID-19 emergency. In that situation, we talked about the possibility of installing this CQ model in order to make it possible to transmit the right signal to an automatic opening door system. In fact, we know that one of the, let's say, one of the stronger means of diffusion is represented by surfaces. So we have to avoid to touch surfaces and handles. And in this case, the capacitive sensors make it possible to open a door without handling any handles. If you have lost this webinar about solutions against COVID-19 and you want to deepen the knowledge about that, you can find the video on our YouTube channel, and I invite you to subscribe to our YouTube channel and to see this video and videos of other webinars that we do and that we are doing in the future. Okay, so finally we arrived to let's say the practical part of this lecture, one of the most fascinating parts of our webinars. And in this case, we want to show you how to adjust a capacitive sensor, in particular by considering two different modes. In first case, the by teach-in button, and we are considering a C12 model. In the other case, by trimmer, considering a C18 model. But what we are going to learn today is applicable also to other cylindric models and to the QC55 series. So we can start now by considering the, let's say, adjustment by button. So as you can observe in this video, we have just mounted a C12 sensor. Okay, before starting, I want to underline the fact that it is possible for this kind of product to perform the adjustment procedure both through the button and via cable. Now we can start by the button. And the first procedure that we want to show you is how to set the right, let's say, sensing distance. So first of all, we have to enter the teaching procedure. How? By simply pushing the button for 3 seconds, as Giovanni is showing you. Now the LEDs are blinking and we are ready to push the target surface towards the active head. Okay, once we have reached the desired active head, we can, let's say, make the sensor acquire this position by simply pushing the button for just 1 second. Now you can observe that the yellow LED is activated when the target surface enters the desired region, the desired distance. Okay, the second stuff that we want to show you is the possibility of adjusting the sensor with the maximum possible sensing distance with these installing conditions. How to do that? First of all, as always, we have to enter the teaching procedure by pushing for 3 seconds the teaching button. The LEDs are blinking, as you can observe. And now we can perform the adjustment procedure at infinite, in other words, without any target. Okay, and now you can observe how the target surface is detected at the maximum possible distance. And the game has been played. Now, we want to show you also the way of changing the logic, because as I said before, the sensor can work in normally open or in normally closed logic. Now it is working in normally open logic. As you can observe, in fact, the presence of a target makes the signal equal to 1, while the absence of the target itself makes the signal equal to 0. Now we want to change the logic and skip to the normally closed one. How to do that? Let's push the teaching button for 8 seconds and wait till the LEDs stop blinking. Now you have seen, after the LEDs has stopped blinking, Giovanni has pushed for just 1 second in order to skip from one mode to another one. And now the sensor is working in normally closed logic. Okay. But another possible procedure that we can apply is the passage from the unshielded installation condition to a flash mode, to a shielded one. So now Giovanni is going to change the installation condition by putting inside the sensor, inside the support. But what's going on now? Let's observe the yellow LED. You can see that it's activated. Why? Simply because we have already, let's say, set the sensor with the desired distance when it was installed as an unshielded sensor. And now the result is that he is reading the walls all around the active head, the walls of the support. It's not correct in this case because we want the sensor working in shielded, in flash mode. How to do that? We have, as always, to enter the teaching procedure by pushing the button for 3 seconds. Now we are inside into the teaching procedure. We push the target surface towards the active head and we teach with just 1 second, pushing with for just 1 second. And now we can see that our sensor correctly works also in flash mode. Okay. Now, at last but not least, we want to show you the possibility of reset the factory settings. So we want to come back to the unshielded configuration, normally open logic, and the maximum possible distance with these installation conditions. But we want to do that now not through the teaching button, but via cable. How? We have to connect the white wire to the negative pole and keep it connected for 16 seconds. So please be patient and wait till the procedure gets the end. Okay, now the LEDs are stable, and we know that we entered the factory settings. As you can observe, the sensor is working in as an unshielded product in normally open logic. And now we can, let's say, push the target surface near the active head in order to see that the sensor is able to detect the presence of this target surface at the maximum possible distance. Okay, with the C12, that's all, I think. And we can have a brief recap, because I know that we have seen a lot of stuff. So what we have learned, first of all, we have learned to teach a capacitive sensor of C12 series using the teaching button. So we have learned to enter the teaching mode by pushing for 3 seconds, and then we have learned to acquire the desired position. Through a similar procedure, we saw how to set the maximum possible distance, and then we have seen how to skip from the normally open logic to the normally closed one. Then we have also learned how to use the sensor in shielded mode. And finally, we have learned how to reset the sensor with the factory settings. Okay, now we are ready to go on with the trimmer teaching. And as you can observe, Giovanni has mounted this new sensor, which is a C18, so M18 capacitive sensor. Here, don't worry, the teaching procedure is quite easier with respect to the previous one, because you have simply to push the target surface near the active head, and then you have to adjust the power emission by turning the trimmer towards the minimum or maximum values on the basis of your necessities. And now you can see how the sensor can work within the desired distance. In fact, now Giovanni has increased the power, and the sensing distance has increased itself as a consequence. Okay, thank you, Giovanni. Now we can come back to the presentation in order to get a general recap of the today lecture. What we have learned. First of all, we have seen, let's say, a brief explanation of the capacitive technology, so of how physically a capacitive sensor works. Then we have we have had a general look at the capacitive sensors portfolio, starting with the exploration of different series: C12, C18, CE with diameter 20, CT and C30 with M30 thread, and cubic sensors, CQ50 and CQ55 series. Then we have seen some interesting applications, and finally, how to adjust a sensor by focusing both on the teach-in mode with a C12 sensor and also to the trimmer mode with the C18 sensors. But we have seen also that this mode is applicable also for the other cylindrical sensors and for the CQ55 series. Unfortunately, our lecture today finishes here, but a lot of other stuff we could say about the capacitive sensors. So if you have some, let's say, curiosities, if you want to ask something or also provide some precious feedback, please write us at info@microdetectors.com. And in order to keep yourself always up to date with respect to the news, please always visit our website, microdetectors.com, and do not forget to subscribe to our YouTube channel and follow us on LinkedIn. I remind you that all of our master classes are recorded and the videos will be published on our YouTube channel. So if you have lost some passage or if you have lost some previous masterclass, you can see those let's say videos on our YouTube channel. Okay, thank you very much for your kind attention and your time, and see you soon at the next webinar. Bye bye.